Hi, everyone. Thanks for coming out. My name is Rowan. I work as a program manager on the .NET team at Microsoft. You're here, hopefully, because you want to hear about ML.NET, which is a new machine learning framework that we announced at Build, currently in preview. So everything I'm showing you today is on preview quality bits. Things are likely to change. So ML.NET, like I said, is a machine learning framework. Like everything in .NET, it's open source. And because it runs on .NET, it's cross-platform, meaning you can use it on Windows, Linux, Mac OS. ML.NET is built for .NET developers. So what that means is it's targeted at .NET developers who want to branch out into machine learning. Obviously, data scientists, folks that work in machine learning, have tools that they use for that, and we're not trying to take that part of the market. We're trying to provide an option that is easy for .NET developers to go out and start using machine learning in their applications. When we think about machine learning solutions, there's kind of two categories we can put them in. There's pre-built things where the model's already created for you, things like cognitive services where I can give an image or some text, and the model's already trained to give me back some information about that. On the other end of the spectrum, we have custom models. This would be where there is no pre-existing model that I can use, or I have something very domain-specific where the pre-existing models don't really work for my situation. ML.NET falls into this second category, so that's what we're focusing on today. I'm going to do basically a demo for the rest of the time. That's all the slides. Because this is a short session, I'm going to use some code snippets. I don't really want to just spend the whole time walking through code that I've already written, but in 20 minutes we also aren't going to achieve much if you watch me typing code, so we're going to be pulling things in. This is also going to be a quick walk through a scenario, and I'm going to send you off to some other sessions at the end where you can get more detailed look at ML.NET. For our scenario, we have a piece of music, but the problem with a piece of music is that some of the notes are missing from it. I'm going to swap to my demo machine. And here we have the piece of music, and the missing notes are highlighted by the vertical bars you see dropping down below the music. Now, I've inserted a pretty subtle placeholder, so we'll just go through and play this. Yeah. So obviously, that's not what we want in our music. Now, there are rules about music. What notes sound good together? As developers, we could go find those rules and then write code. But that would probably take a while because the rules behind music can be quite complex. We have a huge amount of data of existing songs that already give us an idea of what notes sound good together in song. So what we're going to do is use that existing data, train a machine learning model, and then we're going to use that to predict what notes should be inserted in the missing places. The data set that we're going to use comes from UCI. And it's a data set that has some songs, and it basically just pulls out the melody of the song. So the music that we just listened to, a very simple melody. The data set I have in Visual Studio here. And each row in this data set represents a song. So that would be the first number you see, song 1, 2, 3, 4, 5. And then there's a huge string of data that identifies which notes, how long they are, whereabouts they fit within the music, etc. Now, the first thing we do when we're looking at training a model is we need to do data manipulation to get the data into the right shape for our model. So in our case, here's a visual representation of the data that we're getting from the UCI data set. Notes in music are grouped into measures. That's the things between the vertical bars. So we're going to focus on each measure. And as you know, notes are assigned letters. And we're going to twist the data to look like this. So we're going to say, when there's a B, it also occurs in a bar with an A, another B, and a C. So that would be this first row here. And we're going to repeat that for every measure and for every note. Because machine learning works better with numbers, we're going to go through and assign numbers to the notes. Music doesn't start at A, it kind of starts at C, so we'll give that 0 through 11. And then we'll also use those for the note. The goal of what we're trying to do with ML is we want to predict this note, which is called the label, given all of these inputs, the other notes that are in the same section of music. And so those are called the features that we're trying to predict on. So let's run through this in Visual Studio. I have a separate project where I'm going to build the model. Now, I don't want to do it in my actual client application because I don't need to rebuild the model every time. I need to train it once on the data set and then take that completed model and put it into my app and use it to predict notes. So we're working in a console application here. I've already implemented a manipulate data method. I'm not really going to go into this. The way you manipulate data, super dependent on the data set you're working with. In our case, it's a small amount of data, just 100 songs, which translates into about 5,000 rows. So I chose to load the whole thing into memory and just write it out to a CSV as I manipulate it. Obviously, with a larger data set, you might take a different approach. Let's run the app. So my data manipulation routine finished, and it's outputted this modified CSV. And so if I load that up, the first two are just kind of debugging. So it says which song it came from and which section of the song. And then the rest of the notes here represents that data that we just looked at on the slide. It says the note, and then it says whether the other notes are present in the same measure. OK, so now that we have data in the right format, it's time to go ahead and actually create a model based on it. Now, I have ml.NET installed, so that would be the Microsoft.ml NuGet package. And one of the types in there is a learning pipeline. The learning pipeline is the main API we're going to use to define the process that we go through to create our model. The first step in creating our model is to load the data up that's going to be part of the model. Our model's coming from a CSV file, so we're going to use the text loader. I give it the path to the file, it has a header row, and the separator is commas because it's a CSV. I'm also defining an object model here, and this is the object model that represents the input I'm going to give to the routine. I'll go to the definition of this. So this is the note number that we're trying to predict. Now, obviously, when we do an actual prediction, this will be null because we don't know it. But when we're training the model, that's going to be the known note number. And then below that, we have columns for all the features that we talked about, the other information that we do know about the notes in the bar. Now that we've got the data loaded, it's time to give ML.NET a bit more information about how to interpret our data. So the note number so far is represented as a numeric value that could have any number of values up to the limits of the CLR type. But in our model, there's only a set number of notes. So we're going to transform this into basically an internal type that ML.NET is going to use to represent the buckets that this note could exist in. And so instead of using a float, it's going to use an internal type. So to do that, we copy the note number into another column in our data set called label. Label is the column that ML.NET needs to detect and then calculate based on. And then we use this class called a dictionarizer, which is going to take our float number and transform it into the buckets of data, 0 through 11. We go through a similar process with our features. So we had a whole bunch of columns that make up the input data. ML.NET wants all that kind of combined into one thing. And so we combine all that into a column called features. Now we've defined the data, it's time to actually go ahead and train our model. So on the pipeline, we're going to add a new trainer. Now, I'm not going to drill into the reason I'm choosing this class, but this is the appropriate trainer for the problem that we're trying to solve, where we have a set number of inputs and we're trying to classify the predicted output. Now we need to tell ML.NET, once it's done the prediction, how do I output that prediction to the final result? The result I'm trying to output it into is this predicted note class. And you can see I have a single column here, which is the note number that we expect as the output. So to tell ML.NET how to do that, we just go ahead and add this bit of code, which is basically saying, when you get the calculator result, go and convert it from that internal data type I talked about, which has the 12 buckets, one for each node, convert that back into a float so that we can use it in our application. Now that we've trained it, it's time, we've defined all of the process for creating our model, it's time to actually go ahead and create the model. Everything we've done so far hasn't actually caused any code to execute. It's just been setting up the logic that it's going to flow through. So we're going to create a model variable, and we're going to take the pipeline and train it. We tell it what the input and output is. So this is going to be the note prediction input, and we're going to output into a predicted note. Oh, not that. That. Now, having the model in memory is no use to us here because we're not actually going to use it in this application. So we need to go and write it out to disk. And I already passed in the path that I want it on. Of course, this is an async operation, so I will await it. OK, let's go run our application, and we should get a model. You'll see a bunch of output that comes from ML.NET, just giving some information about what it's doing internally. That completed, so if we go to our output directory, we will see musicmodel.zip here. So when ML.NET creates a model, it's a zip file with a whole bunch of information in it. Now, before we go use it in our application, it'd be good to test this model out just to make sure it's actually working. So I'm going to go to our test model method. So here I've created some input. So I've said, we know the key signature. This is just another aspect of music that we're using as an input. And we're saying that in this section of music, this measure, note 8 and note 11 are present. And we want ML.NET, based on the model we created, to tell us what other note would sound good in that bar of music. So we need to go load up our model. Now, in this application, we had it. In this application, we had the model in memory, but I actually want to test loading it from file because that's what I'm going to do in the other application in a second. Then from here, we can say the output equals. We're going to predict based on the input. And then we want to write the note number out to the console. So this would be output note number. Let's go run, make sure it works. OK, so it said note 9, which happens to be an A, would sound good with these other notes. Now that we know we have a working model, let's go take it and integrate it into our client application. So I'm going to go copy the zip file. And we'll close down our console app and move over to our client application. I can just do a straight paste in here. So music model is added to our project. I'm going to go and set it to copy to the output directory so that our application can consume it. Now, when the music loads, I already have it running through this service called a music repairer. But at the moment, it's not implemented. So this, it basically takes in a set of notes. Some of them are missing, which is represented by a note number of 0. And we're going to go ahead and predict what those notes should be. So we need to load up our model. So again, this is the same code that we just wrote in our test application. And from there, based on the note we have here, we need to predict. So we need to get the notes that are in the measure. We need to get those into our input prediction. So we'll call that input. And I have a helper method already, which is going to take the list of notes and convert it into that input object that we already saw. And then we're going to predict based on that input. And now it's time to actually go change the note number. So we're going to say note.note, which is the note number. And at this point, we know that it's an A or a B or a C, but there's lots of A's and B's and C's. There's deep bass notes, there's high treble notes. So I have a helper method that's going to go and find the note that's closest to the other notes in the bar. So I call that adjust to measure octave. So we pass in the result, and we pass in the known notes. And like I said, that'll just work out which C is going to sound best. Now let's run again. We see here the notes that it predicted. I've got them represented in red just so it's easier to follow along. So I'll go play. Okay. Now, in that one, we were missing just a few notes. I was interested what would happen if we had some data where we were missing a lot of notes. So the music is loaded from this JSON file, so melody damaged. And you can see in here we have a few notes set to 0. I have an alternative version of it here where we have a whole bunch of notes set to 0. Almost every second note is. The class responsible for loading it is this one here. So I'm going to go and change this to my very damaged. Run again. We'll see from here a lot more red notes. These are the notes that ML.NET predicted. Go ahead and play. Okay, so that's ML.NET predicting music. So before I send you off on your way, there's a couple of things I want you to be aware of. So if you're interested in learning more about ML.NET and getting started, the URL at the top is the place to go to. There's information and some simple tutorials. This was obviously a super quick overview. Very soon, we have the Introducing ML.NET session, which is going to be a 75-minute deep dive into what ML.NET is and everything that you can do with it. And then later today, me and a couple of other colleagues from .NET are going to take this music demo and a few other AI solutions and turn it into an interesting show of things you can do with AI and ML. With that, please fill out evaluation forms for this and every other session. Thank you very much for your time.